All right. All right, guys, let's get to page 3 of this AP Calculus review. I'm going to share my screen and get us going. Here we go. We're talking about factoring. So now we have every type of factoring. You're going to really need to be good at factoring when you go into calculus. It's got to be second nature to you. So in this first two examples is GCF. I'm only going to work the first example, and the other ones you can do on your own. But if you notice in problem 1, when you do the GCF, you look for the greatest common factor of the coefficient, which is the number in front of the variable. So we see 30, 18, and 6. That's going to be 6. So I notice that 6 is going to be divided out. And then I look at my lowest exponent for variable comparison. X to the 5th, X to the 3rd, X to the 3rd. So X to the 3rd is going to be what I factor out, because that's what's common in all 3 terms. I see Y to the 3rd, Y to the 4th, and Y to the 2nd is going to be Y to the 2nd because that's what's common. So we're dividing that out. So when I divide 30 by 6, that leaves me 5. With the exponents, I subtract. So 5 minus 3, that leaves me X to the 2nd power. 3 minus 2, Y to the 1st power, plus 18 divided by 6, coefficient 3. 3 minus 3, there is no X term. Y to the 4th, 4 minus 2 is Y to the 2nd. Plus 6 divided by 6 is 1. X to the 3rd, X to the 3rd. There's no division there. It's just going to be 3 minus 3, which is X to the 0, which is really 1. Same thing with Y to the 2nd. 2 minus 2, 0. Y to the 0 is 1. So all I have down here is 1. That's my factor form. My GCF is 6x to the 3rd, Y to the 2nd. All right. Let's talk about trinomials with the first term is 1. So again, x times x is x squared. I see a plus and a plus here, so that's a plus and a plus there. What are my factors of 26? My factors of 26 are 13 times 2, 1 times 26. Which pair do I add up? Which pair do I multiply to get 26, but yet I add them to get 15? 13 and 2, that's my factored binomials. That's my answer. If I want to prove this, 13 times x is 13x. 2 times x is 2x. When I add them together, I get 15x, which is my middle term. And 13 times 2 is 26. So that's one way of proving it. All right. So now in the second case, we have a trinomial that's not equal to 1. Okay. So let's jump into that case. We're going to show you a method called the diamond method. So here we go. I'm going to turn this sheet over. 5x squared minus 18x plus 9. Here we go. So I'm going to multiply 5 times 9, and that gives me 45. Right? And I know negative 18x goes there. Okay. Okay. So I'm going to set up my boxes here. So watch. This is what I know. What numbers multiply to give you 45? 5 times 9. What else? 5 times 9. 15 times 3. Okay. So 5 times 9 is 45, but I also got to add them to get negative 18. So I know 5 times 9 is 45. 15 times 3 is 45. But I know negative 9 plus negative 5 times plus negative 5 plus negative 9 is negative 14. And negative 15 plus negative 3 gives me negative 18, which is here. So I know my two numbers are negative 15 and negative 3. I know that for a fact because I'm going to add these two to get this number, but I'm going to multiply them to get that number. So now let's talk about how we're going to factor them. Well, this is what I know. I know 5x to the third is here, 5x to the second is here, and that 9 is right here. So I've got to figure, so that means that negative 15x is here, and negative 3x is here, because these two terms give me this term. So let's walk through this. Let's factor this, because now we have to figure out what are my two factors. I'm going to find it from here. So let's do a comparison. 5x squared and negative 3x. What do they have in common? They have x. When you compare these two, they have x. Right? Come right here. What do these two have in common? 5 and negative 15, x and x squared. They at least have an x, but they have 5 and negative 15, so they have 5. Right? If I compare these two, what do they have in common? Negative 3x and x. They have, well, no, that's not what I'm looking at. I'm multiplying what times x to get negative 3x? Negative 3. What am I multiplying times 5x to get negative 3x? Excuse me. What am I multiplying times 5 to get negative 15? I'm multiplying negative 3. So let's go over this again so you can see this. Negative 3 times 5 is negative 15. Negative 3 times negative 3 is 9. X times 5x is 5x squared. X times negative 3x is 3x squared. So we have our factored form. 5x minus 3 times x minus 3. This is our these are our factors right there. So for this problem is 5x minus 3 times x minus 3. Now, that's a trinomial case. Here, this is a difference of squares. So let's go to the back. 8x squared minus 162. Difference of squared. A squared minus b squared equals to 8 plus b times a minus b. That's the factor. That's the form you're thinking about. Let me back this up. We can think about with this problem. Well, we have to look for the GCF first. See, in this problem here, there was no GCF. 5, 18, 19, the highest number of divisors in all three of these is 1. So if 1 is a GCF, then there is no GCF. But here, what's the highest number of divisors to 8 and 162? You got it, it's 2. So I'm going to divide 2. 8 divided by 2 is 4. 162 divided by 2 is 81. So how do we do the difference of squares? Both of these terms have to be perfect squares. What's the square root of 4? 2. What's the square root of 81? 9. So I'm going to factor these out. So I know I'm going to have a plus here and a minus here, like I have here. But what's the square root of 4? So 4x squared, 2x. What's the square root of 81? 9. It's factored. You're really going to have to be good at this in calculus. You're going to see a lot of these problems where you got to factor them and work problems backwards and see these calculus problems in different forms. So it's very important that you're good at that. Okay, that's the difference of squares. What does the difference mean? Subtraction of squares. Okay, now we're going to talk about a difference of cubes. So difference of cubes. That's our formula right there. Okay. So we have a difference of cubes. So we have 8 to the third minus 125 y to the 6. So both the 3 and the 6 are cubics. They can be cubed. 8, the cube root of 8 is 2, because 2 times 2 times 2, 2 written as a factor 3 times is equal to 8. 5 written as a factor 3 times is equal to 125. So the cube, so this can be cubed. So the cube root, this is how I'm going to do this. The cube root of 8 to the third is just 2x. So I know 2x is here. Okay. And the cube root of 125, y to the 6, negative 125, y to the 6, is going to be negative y to the second. Well, yes. So that's your first form. Now, x squared is this number right here, taken to the second power. That's this term. So 2x squared is 4x squared. Plus these two multiplied. It's going to be a plus there. These two multiplied. These two multiplied. So 2x times 5x to the second. That's going to be 10xy squared. Then this term, which is y, you see y here and y to the second. This term right here, which is here, to the second power. Sorry about that. Sorry about that. That was these two multiplied right here, which is 10x to the second power. And then here, this term, which is here, taken to the second power. So negative 5 squared is 25. 2 times 2 is y to the fourth, which is here. So that's an old, that's factoring, you're factoring the difference of two cubes. Okay, that's what you're doing there. You're factoring the difference of two cubes. Let's go ahead and look at the other case where you had the x to the third. Well, no, we'll leave that to you. Okay. All right, so that answer's on the back. Okay. Let's talk about perfect square trinomials. That's 9x squared plus 24x plus 16. So here's our original problem right here. They want a perfect square trinomial. So that means we're going to factor these and get the same thing. Okay. So look at 9. What number times itself gives you 9? 3. In this case, 3x. 16. What number times itself gives you 16? 4. That's your answer. It's factored. So this is 3x plus 4 to the second power. Okay. So because it's a perfect square trinomial, 3 times 3 is 9. 4 times 4 is 16. Mr. Gamber, how are you getting the 24x? 4 times 3 is 12x. 4 times 3 is 12x. When you add them together, you get 24x in the middle. So it's 3 plus 4x in parentheses to the second power. That's a difference of, that's not difference of two squares. That is a perfect square trinomial. Okay, almost done. All right, let's talk about grouping. Five x to the third was 9x squared minus 15x minus 27. So when we group things, if we want to, in this particular case, we're just going to put two things together, then factor from there. So let me show you what I mean. Okay, in this case right here, if I take 5x to the third was 9x squared and separate that from 15x, right? What do you see here? 5 and 9 cannot be factored. What do you notice about x to the third and x to the second? What's common in both? x squared. So that leaves 5x plus 9. Let's come over here. We're going to factor out the negative. If you look at 15 and 27, what is common? 15 and 27, the common factor is going to be, it's a negative 15, negative 27, it's going to be negative 3. So that leaves 15, negative 15 divided by negative 3 is 5x. Negative 27 divided by negative 3 is plus 9. What do you see common in both? GCF. So that goes in front. What's left? That's factoring by grouping. Okay, GCF is what's common in both. You write it in front. The two terms here, put them here. Okay. All right. I'm going to stop right there.